Hi everyone, and this is the last talk of our Singapore track. For today, we will welcome Nicolas Delsaux to the floor very soon. Just a quick logistic thing about his camera, so that you can see his face as well. Nicolas is going to talk to us about architecture and specifically C4. And can C4 see forward? We're going to say that in a moment. All right. Hi, Nicholas.
Hi, everybody.
All right.
Wait, I will just try to change the used camera because this one is not the good one. Let me just try that. Up. Not change it yet. Yeah, I'm very. Anyway. Super. Bon. Okay, listen. I will not change camera because that's enough time loss. So let's try. Let's start. Okay, so I didn't expect the Spanish Inquisition, neither those technical difficulties. Anyway, the title is a pun because I love bad jokes. I have an obviously terrible sense of humor. I will talk about C4 architecture model and how to use it and to extend it. This won't be a presentation of C4 model because Simon Brown does a way better job than anything I could do about that. So I will talk a little about C4 model and extend this vision forward. Who am I to talk about that? So this introduction is general. Okay, it's not specific to Zenica. For Zenica, I'm a technical director in the Lille establishment, and specifically in one of the agencies. And I'm a Java developer since year 2. This will, I think, this will appear later. And we will talk now about C4 and the goal of this model. I'm a Java developer since a long time, and as such, I have had to perform architecture tasks. Architecture is a fuzzy concept in programming. That's why I prefer to talk about myself as a Java developer. Okay. And one of the parts of architecturing an application is to document the architecture, making it usable by other people. And it doesn't. Can you make sure okay, the stream moves correctly? So why documenting architecture? Well, it's the answer of Grady book is better than mine. It's because that the code is the truth, but not the whole truth. In other words, a software system doesn't emerge like Athena from the head of those. Okay, it is built by people. It is built in a socio-technical system. There are politics involved. There is a workplace. There are people, and there are other elements. So there are many questions to answer, and code doesn't answer all those questions. But which question do we have to answer? Wait. Okay. There is a little delay in the display of the slides, I have a feeling. Okay, I understand. So there are many questions to answer about code. And like I said, the code only answers the how question. Typically, in a journalist method, I think the first step is to list all the questions we can ask about a project. There is a question of who, which is the team which built the project, and this question has an obvious answer. So it's not very interesting to answer it, and we won't have to ask this question. We won't discuss this question again. There is a question of the when project started, what is its history, what were the steps in the development of this project. There is obviously the question of the what are the solutions we're trying to build. And this question is never answered by the code. As developers, when I say that the what question is not answered, I think you're a little surprised, because you tend to think that precisely you answer the what question, but you don't answer it directly. You answer the what question by answering the how question. The code always provides an answer to the how do we do that step, but the what, the big picture, is not specially answered. There is a question of, well, the question of the where is not really interesting, because code is distributed, the team is distributed, it's not really interesting. But there is a last question, and this question is permanent. Okay, it's a question development team always ask to themselves and to other teams. It's a question of the why. Why did you do that? Why did you write the code this way and not that way? Why did you choose to split your application in these modules? And this question never have a clear answer, or at least it's really difficult to obtain. Typically, in agile project, there are people who know some part of this answer, but to have the whole answer to the why question, it's really hard. And if you have done the Zenica bootcamp with Olivier or any of the technical directors in France, you have seen the talk by Simon Sinek, which say you always have to start with the why, because the why often explains all. So we know there are questions to answer that the code doesn't answer. There is the when, there is the what, and there is the why. Okay? But how to have answers to these questions? Well, obviously, communication is key in such a concern. Okay? You have to communicate. You have to make sure everybody understands both the questions and the answers. And we could talk, okay? We could have developers come at the first day of the mission and have a talk about the project. But it doesn't scale at all. And in our times of epidemics and so on, it's quite harder to have long discussion with people. I don't know for you, but for me, having a long-term video conferences and so on is quite hard, because there is a psychological weight when using those communication tools. So we will put aside the direct storytelling, and we will go to what are the usable tools. Typically, when explaining an architecture, you have some tools. You can use a whiteboard, okay, which is really easy to use, but which doesn't offer coherence. That's to say, two whiteboard diagrams, even when made by the same person, don't look identical. Okay, I don't know about you, but I have already had this experience multiple times, and you create the diagram for a first person first time, and when you recreate it again, even for the same person, you don't put the squares and the arrows at the same place, because you have understood that your first layout wasn't good, or you forgot a point which was in fact important. So first drawback is that you don't have any coherence. Second drawback is that you don't know the lifespan of your diagram, okay? You don't know how long it will stay visible, unless you wrote in the side of the whiteboard, do not erase. I've already seen that multiple times, and it's quite funny to imagine that people have a longest term memory of the architecture of their application, a whiteboard that could be erased by anybody and by error. Okay, your memory literally is written on the sand. a wave could erase it without any trouble. So that's one way to memorize your architecture. Obviously, you can have a better lifespan by embedding your whiteboard drawing in a picture on your smartphone, on a wiki, on anything like that. But on the other side, you can have a dedicated tool. Typically, I'm thinking about architecture tools like visual paradigm, rational whatever. Rational is known for having a long journey of software for UML modeling. You can use Archie or any or Archimate. I think that's one of the better implementations of the Archie system. But these tools have very important qualities in the sense that they are complete. You can fully describe your architecture. But they have one main drawback, which is that it's very hard to export the information outside of these tools. Typically, I've seen a tweet this week informing users that I think it's Asta, which is very happy to finally provide a plant.uml export which allows exporting diagrams into picture. That's to say, going from the right side of this of this table to the left side, going from the architecture model to the architecture scribble. And it's very fun to imagine that in the 20 years I've worked in computers, there are still people which consider that the gap between both is very hard to go through. So, where does C4 stand in this picture? Well, obviously in the middle, because otherwise I won't talk to you about it. So, C4 goes for context, containers, components, and code. Okay, that's the 4 level of details: context, container, components, code. Easy. It's a classical metaphor because it's a map, and it's envisioned by Simon Brown, which is an English architect. Well, he is not English. He lives in Jersey, which is for Singaporean and Montreal friends, little island hidden between Great Britain and France. In fact, they're nearer to France than to Great Britain. It's very, from the picture, it's a very lovely place. I've never gone there, but well. So Simon Brown has made multiple conferences about C4, which have a way better English than what I'm doing now, but which focus really on the C4 model. Okay, I will go further. So let's detail it a little with an example. I could tell as an example. I could use as an example an external project. Excuse me. But use project wouldn't be fun. In fact, the tooling I've built around C4 model is in a project which is called Agile Architecture Documentation System. And I will use this project, which enhances the C4 model and structurizer, as an example, because I think it's a funnier example existing. So let's directly express the whole C4 model in 6 slides, I guess. First level of a C4 model is the context. Context details the system you're studying and its interactions with the external world. One point which is important to note about C4 model is that Simon Brown insists really hard about the legend, which is on the lower right side. Simon explains that multiple diagrams suffer from the lack of a valid legend. This legend will allow a reader now, in 1 year, in 10 years, in 100 years, to understand that diagram, provided it understands the language used. Okay, the context diagram puts the system under study in its context, like the context says. Okay, so in this diagram, you will see the users, you will see the externals, the users be there internal or externals, and the systems, the other system our studied system communicates with, be there internal or external again. So in our example of Agile architecture documentation system, it's a very simple system, as you can see, because it only communicates with two kinds of users. The architect, which produces the documentation, and the stakeholders, which read the documentation. And that's all. You don't have any kind of external system. So that's the first level, that's the context. Now, using the map metaphor, we will zoom in our system, okay? And the first level of zoom is the containers. The containers are the big elements in our system. That's the elements which structure the content in our system, okay? In our case, we have in Agile architecture documentation a Maven archetype, a Maven build. So we use Maven build to run, to generate some ASCII doc and to use as a plugin an architecture base which will allow us to inject data in our architecture model. We will go back to that later. You see that those containers are big components, okay? But this component, you have to understand that they depend upon the build system. As a consequence, those containers may not be Docker containers. They can be Docker containers. Typically, if you're building a microservice architecture, you have an identity between the project for the code you build and the Docker containers that are deployed. Okay, in a microservice architecture, you will often find containers being Docker containers. But in a monolith system, there will be one Docker container representing the whole system and multiple Maven or Gradle modules representing the various containers of your application. So the C4 containers are not specially Docker or Maven or Spring or whatever containers, okay? But they must be significant elements of the system architecture. How to recognize them? In fact, it's quite easy, okay? The containers appear by themselves. Typically, when you're building a system, you know there are two important parts of your system. Those two important parts are your two important containers, okay? You may have a front end or on the back end. Those are valid containers. You can have, I don't know, an admin interface, an admin container or on the user container, and these will be valid containers, okay? So you see they depend really upon the system which is built, but they are big elements. And those big elements can in turn be zoomed in to have components. Typically in our base container, which I described earlier, you have those various components. So you have an architecture documentation builder, various architecture config extension, a metadata inferer, and so on, and so on, and so on. I could detail that long, but it's not really the important part of this presentation. I use this diagram more as an illustration than as an explanation, okay? And you see that I'm very bad at layouting my diagrams, because this one goes out of the slide. Sorry, my English is really insufficient. Okay, this component, you see that I don't know for you, but I've worked with various component system in my career. Okay, so component. If your framework implements the component concept, that's cool. And if you think about it, there are multiple frameworks that implement component system. I can think easily about Spring, GWT, Java EE, Swing, Vue.js. I can think about all the web micro framework which expose roots as various classes, and so on and so on and so on. In fact, framework exposing components are, I think, the basis of computer science, because that's the only way to have a small fragment of code emerge. Okay, so you will find components. That's not a problem. They will always appear. So you have components, and now, in fact, if I go back to the, let me go back to the example. If I look at this component, the detailed view of those components are code elements, okay? And it's quite easy to go from components to code. So, in fact, there is no code diagram as such in C4 model. It's simply that the components are detailed enough to reference code elements. And really, it's very easy to go from the components to the code. Okay? So, now I've explained the C4 model. I've explained the map. It's very interesting, because a map, when someone searches for a road, it is a very good tool. Okay? But I think there are missing elements in. I don't say that Simon Brown idea is bad. I say that the C4 model is insufficient to answer all the questions we previously detailed. Let me zoom in on those questions. Typically, the first thing is that diagrams may be potentially inconsistent. For now, I've always explained that you have to draw three levels of diagrams to zoom from your system to the code that implements that system. Okay? So if you draw those diagrams using, I don't know, Draw.io, Visio, or any drawing tool, the diagrams may be inconsistent. And that's a real risk, because inconsistent diagram will get you lost 100% of the time. The second element is that, obviously, the diagrams may not answer all the questions. The question of the history of the project can be answered by a map. The geography can't explain the history. You won't answer neither the why question. And there are other questions that aren't answered. Finally, the diagrams may not be up to date. If the person which is responsible to have diagrams maintained is sick, is lazy, don't want to do the job, which some ways happen, your diagrams won't be up to date. And a map which is not up to date has absolutely no interest. So there are these questions. Let's try to first answer the first risk I mentioned, the fact that diagram may be potentially inconsistent. The question is simple: how to make sure our diagrams are consistent? There is an answer to that, which is quite simple: is to back those diagrams upon a model. I don't want to talk here about the model that is maintained in architecture tools like Rational that I mentioned earlier, or any IBM Architect Studio, or any tool which will put the architect in ivory tower. Okay, because if the architect use tools that are different from the developers, there is no way that the developers can handle the architecture of the product they develop by themselves. In other words, when you do so, you make sure there is a frontier. And if there is a frontier, you make sure there is a power relationship, which will in turn ensure that the product is of bad quality, because the architect will give orders to developers, and developers won't have way to communicate their visions in the term of the model. So we don't want to use a model that developers don't understand in their guts, in a sense. Which is what Simon Brown provides with Structurizer. The slide is again. I hope I forgot to sooner to put the slide in full screen. So I hope you see that this slide is in fact the web page of the Structurizer tool. Sorry for the French accent. It's the only way I can say it correctly. So Structurizer is a tool that Simon Brown, again, developed to back the C4 model on a real, to back the C4 model on a model that everybody can understand. This tool allow users to produce a model that will be used to generate the diagrams, either as code on the left, as text in the center, or using an UI. You can even, in the center, it's written in small, okay, but you can use YAML if you're a YAML engineer. Personally, I'm not a YAML engineer, I'm a Java developer. As a consequence, I will show you some example of the use of the Java part, but understand that, like it said, it's available for Java, .NET, PHP, JavaScript, Python, Go, and so on, and so on, and so on. Because the language mentioned here are the language which are directly available in Structurizer project. Okay, there are even bridges for other language. So, if I go back to the idea of C4 being a context, container, components, and code, how do we express our context? Simply using Java code. Java code is understood by Java developers, okay? It's understood by architects, which often come from a developer background. So it's easy to define our context. This fragment of code that you see on YouTube is exactly the one that I used for generating the first architecture diagram, in which I show the context. Okay, it's exactly the same thing. In fact, I generated this diagram. So you see that it's very simple. You detail the various elements. Here are the persons, okay, and here are the software systems. I add some properties that I will explain later, and I draw the relationship using Java code, and that's all. I have my context. Very easy. In the same way, I will be able to draw the various containers. So I have my archetype, I have my Maven build tool, I have my architecture base, and I have down and under, I will have the ASCII-doc container. Okay. Again, very simple. I add some decoration here with the add property, but it's not so interesting now. I will come back to that later. And finally, I add the components. And for the components, I can thank again Simon Brown, because instead of having to write each component one by one, I can use tooling to discover components from the code. And this is, to my mind, the pearl of Structurizer. It's the ability to go from the code and to generate a model which will be up to date. In other words, each time I will generate the diagrams from using Structurizer, I will be able to get the components that are effectively present in my code. And so to get those components, there are multiple ways to find them. Okay, here I use the structurizer annotation, which means that in my code I have put annotation, the arrobas component annotation in my code. But there are ways to discover components in Spring applications, and I use it on another project, and it's absolutely brilliant. I have put absolutely no annotation, no structurizer annotation in my code, and I have all my repositories, my services, my controllers that appear in my other diagrams. It's a really time saver. Finally, once I have described my context, my container, my components, I can generate some views because it's pure Java code. Okay, I have to generate. I have to say the system that I want to generate the views that will be presented. And again, it's very simple. The first view, which is a system context view, is generated by creating the view, adding the software system and the people, and so on. And that's all. To generate the container views, again, I create a container view and I add all containers. And finally, to create component view, well, I call the create component view and I add those components. So when doing so, I am able to have diagrams that are always consistent. Let me emphasize this again. I am able to generate diagrams that are both internally consistent, which means the data presented is always coherent from one diagram to another, same text, same color, and so on, and externally coherent with the code this architecture documentation is supposed to represent. Okay? And this, the fact that the architecture documentation will be always kept coherent with the code is really important to my mind. It means that the architecture will present to developers a vision, which is the architecture imagines, okay? And when the developers implement this architecture, they don't have to write documentation at all. The documentation will be generated from their work. And it will allow architecture review based not upon reading the code by the architect, but simply looking at the diagrams that are generated, comparing them with the architecture envisioned, and checking the difference. That's all. That's a time saver. That's a way to allow developer to communicate with the architect, with both of them having their vision respected. Okay, it's for me. It's really important. It's really a first step to fill the gap between developers and the architect. So we now have a map which is consistent at all this level and with the code. But there are still questions, there are still problems with that. The first is we still don't answer all the questions. We still aren't able to explain the history of the project. We still aren't able to detail the constraints on the project. And again, if we don't run the code that generates the diagrams from the code, we may not have diagrams up to date. Well, the second point, you will have the tendency to see to say something like, well, let the CI generate that. We will come back to that later. For now, there are other questions, and it's a very interesting moment because I'm talking since the beginning about the difference between the geography, in other words, the map and the C4 model, and the history of the project. And geography often can't explain the history because geography is a consequence of the history. Okay? In other words, that the developers that build the project that will define the architecture of this project. And we, human beings, are we need stories to be told to us. Okay, we can't take a diagram, understand it, and say, okay, that's all the tools I need. We always need to have answers to the why. And this need for a why is really a cornerstone, okay? I don't know how important it is, but remember, everything you have learned, everything you have been attached to psychologically is our stories. Okay, the facts are just facts. There are Excel tables. There are Google spreadsheets. They are absolutely uninteresting. Okay, you won't be invested in them. But once you get the story, once you get the motivations, once you get the art point, okay, the tragedy, and so on, you get emotionally attached to the story, and this emotional attach will make sure that you remember the story and you're able to both remind it later and tell it again. And this story is very important to my knowledge, from my personal history. It's the storytelling part of the architect job, which is really important. Okay, the architect is the bard of the development team. The architect is the people that will have to take the fact that the developer team collects and make it a story that he is able to tell to all the stakeholders. Okay, and it's really, I think it's the most major job of the architect. It's not defining the architecture. It's to tell the story of the development team to both the development team and the external world. And to tell that, I think it's useful to use some tooling again. But this tooling won't take the usual form of I don't know, a software you can freely use or something like that. No, a story as a plan. Okay, a story as a way to be told. In software, it's a thing that is absolutely always forgotten. Look at your specification document. Okay, look at your I don't know how to tell it in English. I forgot the word. Anyway, look at your spec. Look at your user stories. They always tell you some part of the story of the software story, but they lack the big picture. It's always micro stories. Okay, it's always micro quest in video game vocabulary. So we need a big picture story. This big picture story can be told using a plan which is common to most of the projects. Okay, and this plan, again, I must confess, again, this plan comes from Simon Brown. In fact, I've read many architecture documentation plans, but this one is really interesting in the sense that it goes from the start to the end. You know, it tells the story the right way. Let's look a little at this plan. Oh, I forgot that I can't move in the page, except it with no. It's an iframe, so it doesn't work. Anyway, we have the main chapters here. If you look at this plan, you will see that you start with the context. Okay, it's a playground in which you will develop your software. This context is obviously the place where you will use your system context diagram. Okay, the diagram we use later will take place in this context, and you continue with some parts, some chapters, which will detail elements that don't need diagrams, but explain the part of the why. Look at this, the five first chapters. There is the functional overview, which explains what the users of your software are. There are the quality attributes, which explains the level of performance of your application. Okay, the term is for me, French person. It's a little strange to use quality attribute in that case, but after some news, I've understood what Simon wanted to tell, and it's really, I expect my application to support, I don't know, 5,000 users for which the response time is lower than 50 milliseconds per user. So there are then the constraints, and constraints are the elements that come from your context. Typically, in France, we have a tradition of companies defining the usable frameworks, language, methods, and so on. That's the constraint. Typical constraint, as an example, at Decathlon, where I'm working currently, we have to use Spring to develop our application. So that's a constraint. We have to package our applications for Docker. That's again a constraint. We have to deploy that Docker container into Kubernetes clusters. Again, that's a constraint. We have to use Postgres database. That's a constraint, and so on, and so on. After the constraint, you have the principles. Principles are what your developer team consider important. Do they want to do TDD? They put in the principle. Do they consider it's important to separate the view from the model? They put it in the principles. Do they consider it important to use microservice? Again, in principles. And so on, and so on. Those principles can be written at the project start by the developer team, but they can be also discovered during development. Typically, when an application grows, it starts as a little application, okay? The application grows, and at one time, it may become important to split it in different modules, okay? And the way the split will be done is a principle that is currently discovered. You see what I mean? At the instant you decide to split your application in, like I said sooner, an administration module and a user module, you define a principle. Your application will be split according to features and profiles of user. If you decide to split your application according to, I don't know, a database sharding or something like that, it's again a principle. So those principles will define the inherent decisions that will be taken in software architecture part. Software architecture part will contain, of course, the container diagram, may contain the component diagrams, and will use the principles, constraints, and quality attribute detailed later to explain the diagrams. Because the important part of this documentation is to have the diagrams and the explanation of why the diagram takes this form. Like I said, if you use microservice or if you split your application into parts for users and admins, it will appear in software architecture, but will be explained by a text detailing that according to our principles, constraints, and quality attribute, we had to organize our application this way. Okay? Then you have the code, which explains how your code is stored. So typically, you will have links to GitHub, GitLab, and so on. You may have classes diagrams or any diagrams that may help you detail how the code is organized. You will have, after that, a section regarding data. And so in data, you may find your database diagram, again with explanation. You will find later infrastructure architecture, deployment, and parts that are not visible are development of environment and architecture decisions. Okay, so you see that this document provides an explanation going from the start, the context, to the end. If you look at the organization of the chapters, the deployment, which include the way application is deployed in production, is one of the last chapters, because the goal of the development team is to go from the start, the context, to the end, an application that is in production. Okay, so using that documentation model and the diagram produced by Structurizer, you will have very good documentation. Okay, and it will be really easy. But there will be one last point missing. The point is your diagrams may not be up to date, which I explain later. About that issue, after all, we are developers. Okay, what we know is how to develop, and the presentation I've done for now just go from okay, what is C4 architecture and how can we transform our architecture model into something that developers can handle. Okay, so as we are developers, we can use our developers principles on our architecture model. One of the first principle we have as developers is we can use the dry principle. The dry principle stands for don't repeat yourself. In other words, don't write in architecture documentation what you can get from your application. And I think that Structurizer already explains that. In Structurizer, like I said sooner, to get the components of your application, you don't write the list of your components by hand. Instead, you let your architecture system read the components from your application, okay? But we can go way further. In other words, I will show you what I do in order to simplify architecture documentation. Because in fact, for our application, we already have all the information. Okay. Typically, I said it sooner. Our containers are already detailed. If we consider we deploy a monolith, our containers are already present as Maven modules. If we consider we develop a microservice application, our modules, our containers are Docker containers, and in such a case, we can find them in Kubernetes. And we can also find in Kubernetes the containers that configure our access to application, but that we didn't write ourselves, like the ingress, like the service, like any kind of Kubernetes components that we need in our application. In the same sense, we can easily find our components. If we are using any component framework, we can examine the components that we have developed and use this information in our architecture documentation. So we can extract containers, we can extract components, we can even extract other information. What's more, we can also, we already know, we already know how to produce complex code. We use a CI/CD on our products, which are way more complex than simple documentation to go from the code to the production. Okay, we already know how to use advanced code industrialization, so we can use that for our documentation, and that's what I do. I forgot the slide was blank. That's what I do with my system, which is Agile Architecture Documentation. What you have here on your screen is the page that you can find on GitHub. If you go on GitHub and go on Agile Architecture Documentation System, you have a link to this precise page. Okay, and this page, which if you look, takes the form of the plan described in Agile Architecture Documentation. Okay, it embeds the diagrams that have been generated using Structurizer, and it's generated using GitHub Action. So I use CI/CD to get the info to process the information that I have in my architecture model and detail it. Okay. Well, this is quite simple because there is only information that go directly from the model. I have done, in fact, you can do way more than that. A typical example is that I've used in a previous mission. I had applications which were deployed in Kubernetes and which get configuration for access to database from Vault. Okay, so in my documentation module, I used the HashiCorp Vault Java client to read the secrets from Vault and populate my architecture documentation. Obviously, in my documentation, I didn't put neither the logins, the logins, neither the secrets, the passwords. Okay, I only used the Vault Java client to get the URL to access the database. This way, I had architecture documentation, which in the deployment diagrams contain the effective name of the Kubernetes cluster, the effective URL to connect to the database, the effective name of the Kafka topics, and so on, and so on, and so on. I've used this system, I used this system 3 times, okay? I've used it once for a mission in ADO and twice for Decathlon. No, one for Decathlon and one for Call for Offer. And each time, I've refined it to make it more simple to use. And this is what makes me say that it's really a cool way to document your application. Because you have your model, which is described as Java code. If you use Java, you can use C# or anything else. But the fact that your architecture documentation is pure Java code make it possible to generate the architecture documentation during the build of your application. And this provides the final level for really agile architecture. What I mean here is that if your architecture documentation is a module of the application you deploy, your architecture documentation is always up to date and can even be maintained by the developers. That's the developers that will write the ASCII doc file that provide the various chapters. The developer will also, when they write the code, directly update the diagrams and so on. And this way, you will have an architecture that is always up to date, that is always coherent, which can be read by developers, by stakeholders, by architects, and which is really a tool for understanding your project. Thank you for your attention and your courage to listen to my not so good English. If you have any question, I will try to take a look at the chat, and then I will go in the QA section. So if you didn't ask your question in the chat, I will gladly answer them in the QA section. Thank you again. I don't. Adrien, I guess you're muted.
Thank you very much. Thank you very much, Nicolas. As you just said, yeah, don't hesitate to go and ask your questions on the green carpet. And when you leave the room, the conference room of Singapore, do walk slowly in order for open feedback to actually spawn, and you can provide feedback from Nicolas over there. It will be very helpful. Thank you very much. And I guess that's a wrap for our track in Singapore, Nicolas. You're closing it.
I hope it's. I really hope it was a nice closing for Singapore colleague.
I do believe it was, to be honest.
So
it was really nice. I learned a lot.
Let's go to QA.
Thank you, everyone. Right. And that's it for our Singapore track. Hopefully you can find other tracks and maybe other talks. And it was really a pleasure having you here. Cheers.